The video on mass mole conversion problems. Since it is not possible to measure the number of moles directly, we use the molar mass as a conversion factor to solve problems between moles and mass. Now, what is the molar mass? Well, molar mass is the mass in grams of 1 mole of any pure substance. Now, this mass could be atomic mass, it can be formula weight, or it could be molecular weight. But just we have to make sure it is expressed in grams because it says here mass in grams. Now, this equivalent, I have a question mark here because it depends on the substance how much mass will be here. That is why I left it as a question mark. Now, these two fractions, they are conveying the same message and they both are true, even though you see the second one is the inverse of the top one, but they are giving the same information that 1 mole of a pure substance is equals to its mass in grams. That's what it is telling you, both of them. Now, which fraction are we going to pick when solving problems? It depends on which one leaves us with our unit that we actually want at the end. So if we want our answer in grams and we have a starting unit moles, we are going to use this one. If we want our ending unit in moles and we are starting out with grams, we are going to use this fraction. So just look at your question, what is being asked and what is being given. All right, and in these questions, this video, I have already given you the molar masses, but if they were not given, use the periodic table for molar mass of elements. Now determine the mass of 3.50 mole of copper. So this question is asking us to find the mass. This question is asking us to find the mass. Mass means the unit grams. So here, our ending unit gram is given by this fraction at the top. So desirable unit at the top. So with this equivalent, we are getting these two fractions. And where are we getting these numbers? 63.55. Well, it's coming from periodic table. It's already given. It's by the definition that 1 mole of copper is equals to 63.55 grams of copper. Let's start solving this problem. Let's start with the given. So 3.50 moles of copper are given, divided by 1, and this 1 doesn't change anything. It is just to show that you are dealing with the fraction. So always put in their denominator, always write 1. All right, for denominator of the given. Now, I don't want the unit mole. 1 mole of copper. Here, this one cancels. I want grams in my final answer. So I'm going to write like this. Okay. Now use your calculator, multiply them, and that will give you 222.425. Put it in correct scientific notation, moving 2 places to the left, the decimal, because you want only one non-zero digit on the left of the decimal. That's why you moved 2 places. Okay. Now you want to, so this is 222425, 222425. Now here, let's look at the number of significant figures in our given. 1, 2, 3. So 1, 2, 3. You're going to round off here, and when you do that, your final answer will be these many grams of copper. So don't forget this final unit. You must write the unit in the answer because these numbers don't mean anything. Then it is not a measurement if you don't put the units. So make sure you put the units. Now let's try this problem. It's your turn. How many grams are there in 24.7 moles of sodium fluoride? Now guys, just remember, you always go when solving these problems using unit analysis method or any method, you always go from known to unknown. So what is our known here is 24.7 moles of sodium fluoride. What do we have to find? We have to find the mass. So just look at the equivalent, that 1 mole of sodium fluoride is these many grams per mole. That's the molar mass, and already given, and it's coming from the periodic table. There you go. And we are going to use this fraction. So you start out with given, divide by 1, and then pick the correct fraction. That will cancel out the units that you don't need, and that should leave you the unit that you do need at the end. Alright, and then you multiply. You got that. Here, put it in the correct scientific notation and correct significant figures. So if you have to explain how would you convert given moles, if you're given the moles and you have to convert into mass or in grams, what would you do? So you're going to say, we are going to multiply the given moles by the molar mass. So the unit of molar mass is grams per mole. That's the unit of molar mass. Okay. Now let's do this one. How many moles are represented by 98.0 grams of cobalt? Again, the molar mass is given to you, and here is the equivalent. 1 mole of cobalt is 58.93 grams of cobalt. Again, guys, if it is not given, you're going to look at the periodic table. Let's start out with given in this problem, 98.0 grams of calcium. 1. Here, what do I not want in this question? What do I want finally? I want moles in my answer. So moles at the top, here, moles at the top, and I want to get rid of grams, so grams at the bottom. Okay. All right. 1 more cobalt. Okay. Use your calculator, divide them. You're going to get 1.662 moles of cobalt, and it's already 1 digit to the left of the decimal. So you 1, 2, 3, round off at third place. You will get 1.66 moles of cobalt. Now, if you are asked again to write in words, explain in writing, how would you convert given mass to moles? Then you're going to say, to convert grams to moles or mass to moles, you multiply the given mass by the inverse of molar mass, because this is still the molar mass, but it is inverted, it is inverse, right? Because how do you know that? Because you have grams here and moles at the top. Or you could say that divide by the molar mass. It's the same thing. All right. Now again, your turn. How many moles of compound are there in 3.34 grams of H2SO4? So molar mass is given. You are going to start out with what is given in the problem. 3.34 grams of H2SO4 are given, right? And then you are going to pick a fraction that will help you with getting the unit that you need. So you need moles. So pick the fraction with the moles at the top and grams at the bottom. All right, here you go. Okay, 1 mole of H2SO4. So here, these many grams in 1 mole of H2SO4. You cancel the same units. Then you divided them. When you divided, you got this answer. However, you are putting it in correct scientific notation. You're moving decimal 2 places to the right. And when you move decimal places to the right, you subtract from the exponent. So here, 10 to power negative 2. Final answer, 1, 2, 3. In your significant figures are 3 in your given, 3 significant figures. So that is why you rounded off at third place here, the 100th place. Now here, don't forget the units, and you did not. Okay. So here, this problem has just one extra conversion factor that we are going to use. Calculate the moles of calcium atoms in one tablet that contains 350.0 milligrams of calcium. Once again, this mass is coming from the periodic table. Well, 1 mole of calcium is equals to 40.08 grams of calcium coming from periodic table. That's the equivalent. This is the one that is additional, and this is a kind of extension problem. So since they are giving you milligrams of calcium instead of grams, you have to convert this milligrams to grams. So in order to convert milligrams to grams, you need to know the equivalent. This is the equivalent. This is coming from the definition that 1 gram of any substance is equals to 1000 milligram of that substance. And here you can also add 1000 milligrams of calcium. Just put right calcium because we are talking about calcium right now, so we will just put calcium everywhere. Okay, let's start with given. So 350.0 milligrams, this is your given, of calcium. Again, don't forget to divide by 1. Put 1 in the denominator. Now we don't want this milligram, right? What do we want? We want grams. So we are going to pick this fraction so that we have grams at the top. Okay guys, so I'm going to write it like this. 1000 milligram of calcium is equals to 1 grams of calcium. Cancel these units. Now what else? Now I'm going from grams to moles. So which fraction am I going to pick? This one or that one? Well, this one, because this has my desirable unit at the top, moles at the top, and this I need to cancel out. So how much is this? So 40.08 grams of calcium is the mass. Cancel these units for 1 mole of calcium. Okay. Now use your calculator. Top, all numerators are multiplied and divided by the denominators. You're going to get this answer. Now don't leave it like that. 1, 2 and 3 places. Since you're moving 3 places to the right, the power will be negative exponent. Here is the unit. Okay. Now here is it's a similar problem, but what's the difference is that instead of milligrams, guys, it can be any other units, but you want to make sure that eventually you want to come to grams. So you need to know the conversions with the units as well, the measuring unit. So here so what is the conversion factor for kilogram? Well, 1 kilogram is 1000 grams, right? How much is it? 1 kilogram is 1000 grams. So we have to convert this. How many moles of methane are in a gas pipe that contains 1.99 kilograms methane? So first we want to convert this into grams. So since we want to get rid of kilograms, we are going to write 1 kilogram. So we are making the fractions from here, from this equivalent. Okay, 1 kilogram of CH4 methane is 1000 grams of methane. Cancel these units, same units. Now what do you want in your answer? You want moles. Okay, so they are giving you the molar mass. So 1 mole, this is another equivalent fraction. 1 mole of methane is 16.05 grams of methane, right? This is another equivalent. So we use this equivalent. Now we are using this one. So what do I write at the top from this equivalent? Well, I want moles in my answer. So moles will go at the top, right? And I want to get rid of the grams. So in 16.05 grams of methane, they are there in 1 mole of methane. Cancel this and this, same units. Use your calculator, guys, and plug in the values. You're going to get 123.98. And don't leave it like that. You are going to move 2 places to the left, and this will be 1.2398 times 10 to power 2. Again, don't forget to put the final answer with the units. Units are important. 3 sig fig, because in my given I have 3 sig figs. Always make sure that your significant figures are reflecting the number of significant figures in the given. That's what should be in the answer. Well, here in this problem, you have 2 extra conversion factors instead of 1. So this you already know that 1 mole of a substance, like a pure substance, is mass in grams. So how do I know this mass? It's already calculated. It was given here. So we had 2 moles of hydrogen, 2 times 4 moles of hydrogen, 2 times 1, 2 moles of nitrogen, 1 mole of sulfur, and 4 moles of oxygen. And then we figured out the mass of each one from periodic table, multiplied the number of moles, and then added all of them to get this mass. It's already given. If it wasn't, that's how you would do. Okay, so let's start with how many moles of hydrogen are there in 6.60 kilograms of ammonium sulfate. Well, this is kilogram, this is grams. Now I'm going to start out with what is given, and this is my ammonium sulfate. Okay, divide by 1. Okay, I want to get rid of the kilograms. So kilogram I'm going to put at the bottom. Okay, and grams at the top because that's what I want in my answer. All right, cancel these same units. Now what do I want next? I want, a question says how many moles of hydrogen are there in 6.60 kilograms of ammonium sulfate. Well, first of all, I need to also know the formula of ammonium sulfate, which is here, but it is not going to be given. You should know that formulas are important, guys, to have the knowledge. Otherwise, it's hard to tell them when it, specifically when they're asking about the atoms in molecules or formula units. So here you have to, so let's first work on this relationship because this is already defined, right? So this definition is telling you, and what do you want to get rid of? You want to get rid of the grams. So this definition is telling you that for 1 mole of ammonium sulfate, that is the mass for 1 mole. So I'm going to write it here. Ammonium sulfate gets cancelled. I don't want those units. And what do I want? I want moles here. Okay, now this relationship is already defined, that in 1 mole of ammonium sulfate is the mass is equal to 132.17 grams. However, that's not what they're asking. The question is asking you the moles of hydrogen. They're not asking you the moles of ammonium sulfate. So that is why we need another equivalent. Now this equivalent is that 1 mole of ammonium sulfate contains 8 moles of hydrogen, meaning how much mole is contributed by hydrogen in 1 mole of ammonium sulfate. So ammonium sulfate here, 2 times 4, 8. All right, that is how you got this 8. I'm not talking about the rest of them, just 2 times 4, 8 for hydrogen. All right, so I want to cancel out my moles, this one. So the way I'm going to put these, this is going to go in the denominator, this in the numerator. All right. So you're setting up the fractions, and you can set up any way as long as at the end you are left with the unit that you actually wanted. Right? And this is what you want. What do you want? How many moles of hydrogen? So you want the unit moles at the top. Now cancel this and plug it in, guys. It should go give you 399.48 moles of hydrogen. And if you're writing in scientific notation, which I always tell you to, this is what it will be because you're moving your decimal 2 places left. And 1, 2, 3, 3 significant figures, 1, 2, 3, right here. Okay. All right. Now, guys, if you want, I hope this explanation was helpful. Now, if you would like, you can use this mole map, but I always ask you to just use the unit analysis method because the unit analysis is very logical and it's based on working with fraction, and you always end up with the correct unit because other units are cancelled. Okay guys, I hope the video was helpful. Thank you.